Every drum of hazardous waste is tracked from creation to disposal with a manifest. And though it passes through transporters, treatment centers, and disposal sites, if something goes wrong, the original generator is still responsible. This is called the Cradle-to-Grave system under the Resource Conservation and Recovery Act, or RCRA. This system is not just paperwork, it's the law. And when it's violated, the consequences are serious. For instance, a major supermarket chain was hit with a $500,000 fine, plus a $2.75 million civil penalty after the EPA found hazardous waste violations across multiple stores. The primary issue was mismanaged items like batteries, cleaning products, and fluorescent bulbs. Most stores were only generating small amounts, but that waste added up fast. In another case, a parts cleaning and solvent recycling company faced a $1.16 million civil penalty and had to invest another $1.63 million in compliance upgrades, including operational changes, safeguards, systems, or procedures. On top of the fines, the company was told that operations cannot continue without the proper hazardous waste permits in place. These cases show how the law holds different industries accountable and ensures proper hazardous waste tracking in various communities. So, how exactly does the cradle-to-grave system work in practice? Let's take a closer look. The cradle is where hazardous waste first comes into the picture. That could be in a lab, factory, hospital, or other facilities. Under RCRA, these waste generators are required to identify and classify their waste. To figure out if waste is hazardous, there's a detailed checklist to follow. First, is it a solid waste? If it's discarded, it counts, even if it's a liquid or a gas. Next, is it excluded from RCRA? Some wastes are specifically carved out. Then, is it on one of the EPA's hazardous waste lists? And even if it's not listed, it might still be dangerous. If it's toxic, flammable, corrosive, or reactive, it's regulated. Watch our previous video where we discussed how to identify hazardous wastes in detail. Now, after checking all the boxes, the generators must obtain an EPA identification number and maintain thorough records, because once waste is generated, the clock starts ticking on how long it can legally be stored on site. The next phase in the system, known as the journey, begins when hazardous waste is ready to leave the site, and this is where the Uniform Hazardous Waste Manifest enters the picture. This standardized form travels with the waste from its point of origin all the way to final disposal. At every stop the waste takes, someone must sign off, creating a documented chain of custody. Breaking or mishandling this chain may result in a federal law violation. The last phase in the system is the grave. This is where hazardous waste meets its end. This stage takes place at treatment, storage, and disposal facilities, which are among the most heavily regulated sites under RCRA. These facilities are responsible for safely managing the waste through one or more methods. The first known method under the last phase is treatment. This method is used to reduce the volume or toxicity of hazardous waste before it reaches final disposal. Hazardous waste can be treated in several ways depending on the waste type. For instance, neutralization is used for acids and bases, rendering them less harmful. Incineration is commonly used for solvents, contaminated materials, or certain pesticides to destroy harmful components through high-heat combustion. For organic wastes or sludges, chemical or biological treatment is usually used. Meanwhile, stabilization and solidification are often used for heavy metals like lead or mercury, locking them into a less mobile and less dangerous form. The second method for managing waste safely is recycling. It involves reclaiming and reusing hazardous materials to reduce environmental impact and lower disposal costs. For example, spent solvents used in printing or automotive industries can be distilled and reused. Used oil can be re-refined into new lubricants or burned as fuel. Metal-bearing wastes, such as sludges from electroplating, are processed to recover valuable metals like silver, copper, or zinc. If treatment or recycling is not appropriate, disposal becomes the final option. This involves secure methods like using hazardous waste landfills. These landfills are engineered with double liners, leachate collection systems, and groundwater monitoring to prevent contamination.
Another way is underground injection, where liquid hazardous waste such as corrosive or reactive chemicals is pumped deep below the Earth's surface into specially designed wells.
TSDFs are required to follow rigorous standards for design, operation, and monitoring. Moreover, inspection should be conducted, environmental performances must be tracked, and regular reports with regulatory agencies must be filed. Because even in the grave, hazardous waste isn't simply buried, it's strictly controlled to prevent harm to people and the environment. Thanks for watching. If you found this video helpful, don't forget to give it a like, click share, and subscribe to our channel so you don't miss the next video in this series.